Welcome to this video. We will see an example of using data type. We will be mixing different data types and find what sort of errors we're going to have. So this example is a very simple example. As you can see on screen, we are declaring number of data types. We have a byte, X as a byte, and it's 10. Then we have Y as short, and M as character, W as int, and Z as long. So these are the 5 data types you have here. 3 or 4 of them are integer and 1 is character. This is character, which also behave like integer sometimes. Now, if you want to increment X, which byte, by 1, say if it is now 10, we make it 11. This is somehow we're trying to do that, but we're doing it the wrong way. So we're saying X equal X plus 1. 1 here, if I ask you this question, what data type is 1? If you look at the previous video, if you watch the previous video, you will find 1 will be int data type, because any integer number by default it is int. So adding integer data type to a byte data type and storing the result in byte data type will not work, because this X will not be able to hold the 1 as int, and the 1 as int will need 32-bit, or to include 32-bit, although it's 1. And when you add it to X, which byte, which only 8 bits, you will get 32 bits as total here, and you try to store it in 8-bit, will not work. So this will generate an error. Same thing for Y. Y is short, and we're adding int, so we're adding a memory space that is 16 to 32 will produce 32. If we try to store it in 16, it will not fit. And same thing for M chart. Now, all these lines will generate errors, but this line will not do, and this will not do. Why? Because Z is long, big enough, 64-bit, and adding 32-bit to 64-bit and storing it in 64-bit is fine, because still the 64-bit here can hold it, can hold 64. And the same here. W is int, which 32-bit, and 1 is int, which 32-bit. So 32-bit as the result, storing it in 32-bit, you have no issue. So these are the errors you will get, and when you get an error like this, you need to read it. So the first one saying error, yeah, and telling you where is the error, it's in line 12, yeah, incompatible type, possible loosey conversion from int to byte, telling you the one is int and you want to convert it to byte, that's an issue. From large or big to small, there is a big risk there that you lose data. But from small to big, there is no issue, because the big still can hold the small. Yeah, that's the simple logic. Same thing, this is because of the 1. The 1 is int. And you continue. This is the same, and this is the same. And that's it. Now, how we can solve this problem? We want to increment X, we want to increment Y, we want to increment M, but it's not allowing us to do that. There are 2 solutions. The easiest one is we use something called plus plus. So X plus plus means increment X by 1. And when it does that, it'll increment it by adding 1 as a byte. So byte to byte, then will produce no error. So X plus plus will make X is 11. And Y plus plus will make Y 6. and m plus plus will make it 66. And these lines, we have no issue with them from the beginning. So this is the way we can solve this problem. That's one way. The other thing, we can store 1 as a byte in another variable, and then we go back to our code here, and instead of 1 we use the variable. Both will produce the same result. The important point here, if you adding a data type which small to another big data type, you cannot store the result in a small data type. You have to have something that hold the big, because the big data type is the one that's going to control the situation.